recording. Yeah. Okay. So we've got y is equal to 6. Yeah. So there's nothing at the moment in the table that looks like that. But can you see how if I write that as y is equal to 6x to the 0, what's x to the 0 worth? 1. So we've still got just 6.
1.
Yeah. Therefore, dy by dx is equal to, we bring 0 down, multiply it by the 6, x to the minus 1. However, 0 times 6 is
0.
0 times x is 0. 0 times x to the minus 1 is 0, i.e. any constant dy by dx is equal to 0. So when you differentiate, any constants in the function just disappear. Okay?
Yep.
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 Yep. B.
So any constant in function disappears when differentiating. All right. Now the second example here, y is equal to 6 times x. What is the power of x in that function? What power would we put there, but we never bother to write? What power of x is equal to x?
1.
Yeah, x to the 1. So if we put x to the 1, we've still got the same thing. So if we now differentiate dy by dx, we take the 1, multiply it by the 6, x to the, take 1 off, 0. So we've got 1 times 6, and x to the 0 is any number to the power of 0 from the drill at the beginning?
1.
1. So we've got 1 times 6 times 1 is 6. So if you differentiate the term of x of a variable to the power of 1, we just keep the constant. Yeah. So dy by dx of 8x is equal to 8. Yeah. And you always know that, and you'll get used to that and do that really quickly. Okay. So there are a couple of special cases that you need to be aware of.
Mac is a special case.
All right.
Right. Yeah.
So next page has a couple of try these ones on. So you're going to differentiate those. So I reckon about 5 minutes to have a go at those. Yeah.
Mm-hmm.
Leave it with us, Mike. We've got this.
So here, yeah, 25 x to the 4. I'll agree with that.
Yeah.
B.
And then I got 8.4 x to the 2.5.
This
Correct.
is y is equal to 2.4 x to the power 3.5. Yeah. dy by dx is equal to what did you say, Macaulay?
I got 8.4 to the power of 2.5.
8.4 x to 2.5. Yep. C. Y is
C.
equal to 1 over x. How else can we write 1 over x?
We can do 1 to the power of x.
We can write it as bring x to the top and make it -1. Yeah. dy by dx is equal to -1 times x to the -2. Yeah. So that's equals x to the -2, or we could write it as 1 over x squared. Number 2, A. Anyone done that one yet?
No.
Y is equal to -4 over x squared. We need to bring the power of x up the top. So what do? How do we bring the power of x up the top?
Have the minus, doesn't it?
Change the sign. So dy by dx is equal to -2 times -4 x to the -3. -2 times -4 is +8 x to the -3.
Good morning, Logan.
Morning, Logan.
Cheers, turn up.
He's a busy man, mate.
B. Hang on, and the recording was paused. You didn't remind me, Dom. So I'll just go through those again.
Fuck's sake, Dom.
Sorry,
Hey,
boys.
language.
Yeah, he's recording. You can't swear.
Right. So we're differentiating 3 times the square root of x. We have to write the square root of x as x to the power of 1/2. Then we can apply the ax to the n rule. So we bring the 1/2 down and multiply times the 3 times x, and we take 1 off the index. So if we take 1 off 1/2, we end up with -1/2. And then we do the multiplication. So the derivative of 3 times the square root of x, I'm going to write in here, dy by dx is equal to 3/2 x to the 1/2. And then when we've got a different power, or a different, rather than a square root, we've got a cubed root here. We've got a cubed root of x to the 4, which we can write as x to the 4/3. And then that's the denominator of a fraction, so we need to bring it up the top. So we bring it up and make the sign of the index, change the sign of the index. So it's 5x to the -4/3. Then we can apply the ax to the n rule from the table. So we bring the -4/3 down, multiply it by 5, take 1 off the index. Here we've got -4/3. We want to take away a whole one, so that's take away 3/3, leaves us -7/3. Then multiplying out, we end up with -20 x to the -7/3. All okay with that?
Okay.
Right. On your next page, you have a couple of some examples with powers to have a go at. Okay, so have a go at those now, please.